Good afternoon, at least it's afternoon on the East Coast. Hi, I'm Terry Goldberg. I'm the Executive Director of the Northeast Waste Management Officials Association. And on behalf of NUMOA, it's called the Northeast Recycling Council, NERC, and the West Coast Climate and Materials Management Forum. I want to welcome you to today's webinar focused on purchasing standards for low carbon concrete. I'm joined by a colleague, Teresa Blaine, Terry and Teresa today in the webinar. She's with EPA and she will introduce herself. She will be helping to co-moderate this panel today. It's really a pleasure to welcome all of you to today's session. We're going to have three great presentations focusing on this topic and be learning a lot about the carbon impacts of concrete and what states and other jurisdictions are doing to lower the carbon footprint of concrete use and production and use. So for those of you who've never been in a GoToWebinar session before, we are recording this session. We will be posting both the recording and the slides, both on NUMOA's website, NERC's website, and Teresa, the West Coast Forum's website as well. So all three websites will have the slides and the recording of today's webinar posted on them. I can't guarantee when that will happen. I do know that it'll probably be NERC first because they're much faster than we are at posting things on their website. Everyone will be muted during the webinar. We will turn off our webcams during the presentations. We will have some questions after Kate's presentation since she has to leave early, but most of the questions and answers we'll do at the very end of the presentations. If you have a question, and we hope you will post questions. If you look on your GoToWebinar control panel, you can see a little gray row that says questions. If you click on the box with the dash through it, you'll be able to, that will enlarge that function and you can then type in your question, and Teresa and I will be monitoring the questions during the presentations, and then we'll queue them up during the Q&A. If you have some kind of issue with GoToWebinar, I don't know if we can solve it, but you can let us know in the chat, and that's another row, and gray row in the GoToWebinar panel, and it operates the same way. Okay, so we're going to get underway. First presenter today will be Kate Simonen. She's the founding director of the Carbon Leadership Forum and a professor and chair of the Department of Architecture at the University of Washington in Washington State. Connecting significant professional experience in high performance building design and technical expertise in environmental life cycle assessment, she works to spur collective action to bring net embodied carbon to zero through cutting-edge research, cross-sector collaboration, and effective policy development. So it's going to be a pleasure to hear from Kate today. Next, we'll have Jordan Palmieri. He is an environmental scientist and policy advisor in the Materials Management Program at the Oregon Department of Environmental Quality, where he coordinates projects around the built environment, life cycle assessments, and purchasing. He worked on building and zoning codes and served as a technical and policy expert for small housing initiatives. He's advised local, regional, and global green building rating systems and led a program to help Oregon concrete producers develop environmental product declarations, or EPDs, a transparency label focused on disclosing embodied carbon. And finally, we have Dorian Bailey. She has worked with the Materials Engineering Unit of the Construction Management Division of the Port Authority of New York and New Jersey for over 28 years. Her unique expertise in environmental chemistry and materials testing prompted this position geared to quantifying and mitigating environmental impacts of construction. She's recently transitioned to this new role for the Port Authority and focuses on, as the newly appointed Chief of Science of Sustainable Construction. And her focus includes minimizing the embodied carbon from construction materials, promoting avoidance, minimization, reuse, and recycling of construction waste streams, and curtailing localized emissions from diesel construction equipment. She has a master's degree in environmental science from the New Jersey Institute of Technology and is accredited as a certified materials manager and has recently been credentialed as an Envision and sustainability professional. So we have a great panel today, and I'm going to turn it over to Kate. Thank you.
Well, thank you so much. I'm really happy to be here. So I think I'm going to turn off my camera. So hi, I'm here to provide a big picture context of the environmental impact of building materials and the definition of embodied carbon, and then moving on to sort of setting the foundation to the following speakers. We'll talk more specifically about procurement policies for concrete. So high level, constructing and operating buildings has a huge environmental impact. Over the next 40 years, we're expecting the global building stock to double, increasing the equivalent of approximately a new New York City of construction every 35 days. And during that period of growth, the material impacts or embodied carbon impacts are nearly half of that impact. So half related to operating buildings and half related to making them. Another is my is not, nobody sees, do you see my screen?
Yep, we see your screen.
Okay. So when we talk about embodied carbon is the emissions that take place throughout the life cycle of a building material. So that means the emissions from burning fossil fuels to drive a truck, driving diesel truck, to excavate materials, to drive the truck's materials to the factory. It's the emissions that take place at the factory from, say, burning natural gas, but it's also emissions that take place through chemical reactions. So making cement uses an intense amount of fossil fuels as energy input, but also has a chemical reaction that takes place. And then there's the emissions from transporting, constructing at the job site, and all the way through to disposing and end of life. So all the things that are in yellow on this slide are considered embodied carbon, or the emissions that take place for materials over their life cycle. And the blue is the emissions that take place from operating a building. So that's the heating, cooling, and lighting. So when we're looking at building material impacts, we're really looking at those. So I'm still getting a note that says nobody sees my slides. So do you guys see a slide that has factories on it?
Not yet.
No, we can just see a sign that says constructing and operating building has a huge environmental impact. There we go. What is embodied carbon is at the top.
Okay, so I think I have to click 2 buttons twice every time I advance the slides. So let's, when we look at a building per se, when you look at the total carbon impact of a building, that's the embodied carbon of making it and the operating carbon of operating it. Oh, this is going to be. So the embodied carbon emissions are significant. So the pie chart that you see here is the breakdown of global greenhouse gas emissions. And so that's all of the emissions that take place across all of the different sectors. So in the upper right, you can see building operations is about 20%. And then on the bottom right, the golden section, that's the emissions from industry. And if we dive down into emissions from industry, you can see that iron and steel production is about 8% of total global greenhouse gas emissions, and cement is in the 7%. So we're
not on your slide, Kate. I'm sorry to interrupt you, but we're okay. There it is.
Stop for a second.
Okay. We're on the slide now with the pie chart I think you were talking about. Okay.
I'm just trying to restart it because I think something's funky. Now, do you see my intro slide?
Yes.
Yes.
And now are they moving regularly?
Yes.
Now, and you see the pie chart?
Yep.
Okay.
Yes, we can see the pie chart.
Thanks. I think this will work now. So, so when we're looking to understand the impact of concrete, the impact of concrete is dominated by the impacts from making the cement, the binder of concrete. And so when we're looking at procurement policies or reducing the impact of concrete, we're really looking at reducing this almost 10% impact of global greenhouse gas emissions related to production of cement. And when we look at buildings in particular, the focus on reducing embodied carbon is really important because those embodied or material impacts happen up front when we first make a building. So if we look at sort of the upfront emissions, it happen in year zero, and then the operating emissions happen over time. So if we're looking to meet global greenhouse gas reduction targets, we need an increased emphasis on the impacts of materials. And additionally, the impacts of material manufacturing are disproportionately impacting frontline communities. Those, when we track the reducing emissions from manufacturing from a global greenhouse gas emission, we're also looking at the emissions that are more impacting of local impacts as well. So when we're wanting to reduce embodied carbon emissions, there's 4 general strategies to do so. One is to build less. So if we reuse existing buildings or build smaller buildings or less infrastructure, then we are using less materials and thus less impacts. We can design lighter and smarter. So design and engineer to use less materials. There are low carbon material alternatives that would be using switching out from one material, say, to another. So using straw-based materials rather than fossil fuel-based materials. And then the last one is procure lower carbon products. And that's what we're going to be talking about in more detail here today. So on the market today, there are products that are similar or nearly identical performance, but their manufacturing impacts are less, so they have a lower embodied carbon. There are significant numbers of policies at both the city, state, and national level, as well as within corporate and private sector policies. And the Carbon Leadership Forum, we have worked doing research to advance low carbon material options, and that includes Embodied Carbon Policy Toolkit, which has resources of example policies as well as a map in which you can track the different policies that are taking place. And you can see, look at all the policies we got in Oregon coming up. So looking forward to hearing from Jordan upcoming next. So there's a range of different policy opportunities depending on what your embodied carbon reduction strategy is. And if you're wanting to optimize procurement, there are a range of policies that are really focused on specifically selecting lower carbon versions of a specific product and incentivizing clean manufacturing, which means efficient systems or low carbon energy sources. And the most common way of addressing optimizing procurement policy is through the use of environmental product declarations and what is commonly called buy clean policies. So from a procurement perspective, one of the exciting things about looking at that is that public policy or public procurement is one of the largest areas of consuming of both cement and steel. So nearly half of all cement purchased in the US is done with public dollars. And about a third of the embodied carbon emissions of construction in the US over a previous decade can be attributed to public projects. So public procurement can be a way to help incentivize and motivate market transformation by rewarding low carbon material solutions. And it can also help align purchasing with broader environmental, labor, or equity goals. Another argument for using procurement is that or addressing procurement is that it can address what's commonly called a carbon loophole. In many corporate and government carbon accounting practices, there's been a focus on the what is called scope 1 and scope 2, the emissions that take place when you actually combust, create energy, but not necessarily tracking the emissions that take place from making things. So if, for example, a state was tracking the emissions that happen in their state and working to reduce them, but instead you might incentivize moving all of your manufacturing out of state because you would reduce your emissions because you weren't making anything in state, but you purchased things from out of state and brought them in. That would be, those purchased emissions are the scope 3 emissions. And for an average company, supply chain emissions are often more than 10 times the emissions that their direct emissions that they specifically control. So I want to give a little bit of a framework of the policy landscape before handing it over to Jordan. Buy Clean policy first was introduced in California in 2017. There's been bills introduced in 8 states, and some passed and some are under pilot stages. The Federal General Services requirement has requirements for concrete and asphalts coming in this year. And there's additional procurement-related policy task forces underway. There's also programs internationally from the Canadian Canadian government, as well as the UN, looking to align global procurement policies. And I'll point again to our policy toolkit for more details on this. One of the interesting things about low embodied carbon procurement policy is that there's a range of levels, ranging from disclosure, so just requiring people to report the impact of the materials that they choose, all the way to setting targets or timelines that of requiring lowering of those targets over time, or incentives to give financial or other incentives for manufacturers that are lower carbon solutions. So just wanting to share that there's a wide range of action taking place all around. When implementing those policies, needing to understand at what scale they're being implemented, so which projects are going to be included, and also what materials are going to be covered. So many proposals have included things like all just buildings. Other ones include buildings and horizontal infrastructure for transportation projects. Commonly selecting materials either by picking all structural materials, for example, concrete, steel, and wood, or identifying materials that are very high carbon impact, or and so concrete is one of those that's identified as a high impact and material that also has significant opportunities for optimization in the mix design. So with procurement policies are typically using environmental product declarations. Environmental product declarations report the carbon footprint of the product. So in this case, a concrete mix. So here, 1 cubic meter of concrete would have a carbon footprint or a global warming potential of 445 kilograms of CO2. So with each, when there's a EPD that would give you the carbon footprint of that mix, then you can use that to specify or require mixes that meet that carbon footprint target. So I think I'm going to keep us on time. There's just a range of different policies, and strategies about how to do that, ranging from targets, limits, and incentives. And I just want to highlight that as you're implementing these policies that are difficult to comply with, we predict will be less successful, both in terms of difficult to implement, but also in lower actual embodied carbon reductions. So there's a range of different tactics to help facilitate compliance and increase success, providing education and training, pilot projects, and others. So that's an overview. I think we were going to hand it to Jordan next, or see if there were any specific questions now, since I'm leaving on the half hour.
Teresa, are there any questions for Kate?
I don't see any right now in the chat. Oh, we do have one. Let's see. Someone noticed that on the EPD slide, there is a line item for sequestered carbon. Is this a new item in PCR?
So it all depends on the, so no, there's not been a recent change in the product category rule for reporting environmental, the EPD. I'm not sure exactly what they're noting here, but for concrete in particular, no, but there is in an EPD for the wood products, there is, and that there is likely to be evolving standards around that. So that's whether or not you're storing carbon in the material. That's a simple, incomplete answer to a very complicated and interesting question.
Thanks, Kate. I see a few more questions in the chat. One that I think you could probably cover is explaining what the carbon loophole might be and the difference between maybe it's in reference to embodied carbon versus operational carbon.
Well, so the carbon loophole would be most noticeable in, say, the state of California sets emissions reduction targets and goals. And so they are setting policies in place so that less emissions would happen in California between now and 2050. So they would be incentivizing investments in low carbon energy sources. If California, there are cement plants and steel mills in California that have emissions. And if California shut down those steel mills and cement plants, there would be fewer emissions in California. But unless California actually reduces the amount of cement and steel it purchases, it has no global impact. It just looks better for California. And so they've outsourced the production of steel and cement. That's just so a carbon loophole would be then California, it might look in California's accounting practices like they'd eliminated emissions, but they have not tracked the consumption-based emissions or the scope 3 emissions of their purchasing. And so procurement policies help to address the fact that procurement policies and consumption-based carbon accounting addresses the total emissions related to running a state or running a building. So if you ignore embodied carbon, you can effectively have a carbon loophole in that you aren't reporting what you actually are responsible for.
All right. Well, thanks, Kate. I think we're going to hold off on some of these other questions until later in the Q&A, but I know you have to log off right now, but thank you so much.
Thank you. I'm so sorry to not hear the other presentations and be there, so I'll look forward to seeing the recordings.
All right. Thanks, Kate. Take care.
Thank you, Kate.
Jordan, are you next?
Yes, hi, I am here. Just want to confirm that you could hear me and see the correct screen of my slides. How's it going?
Yes. Yep.
Okay, great. All right. Well, I think I'm supposed to keep the video off, so I am going to launch into it. Thank you so much for that opening, Kate. It provides really good context for this next section here. And just in general, thanks for inviting me to this webinar. Really excited to get into the panel discussion and answer any questions you all have. My name is Jordan Palmieri, and I work in the materials management program at Oregon DEQ. I focus my time on the built environment, and we are one of many programs under the large materials management umbrella at Oregon DEQ that works to reduce the material-related impacts across the whole life cycle of materials flowing through Oregon. Today, we're really just going to talk about concrete. And if you want to learn more about some of the work we do in the built environment, feel free to go to builtenvironment.oregon.gov. All right. So today I'm going to give some background on our work on concrete. We're going to discuss some local and statewide procurement policies. We're going to talk about pilot projects. Everybody loves pilot projects. And we're going to finish out with some lessons learned so that all 200 of you that are on the webinar today could take some lessons back to your part of the world. All right, let's talk about some background of how we got into this work here in the state of Oregon. As far back as 2010, we produced a consumption-based greenhouse gas inventory for the state of Oregon. In this inventory, we can see that embodied carbon of building materials, like Kate was talking about, in the red pie slice comprises about 8% of all annual emissions in Oregon. Now, this clearly shows that building materials matter, but it was also clear that other materials like food and beverages, electronics, furnishings, and clothing also mattered. Now, in order to engage with these diverse sectors, we started a project with the Oregon Sustainability Board back in 2014. And the project was to convene businesses across Oregon to talk with them about how to both measure and reduce the carbon footprint of the products that they produce here in Oregon. And we published our research results in this report here, and all these links will be available to everybody afterwards with the slides. And this report came out in December of 2014. And the findings are that really, as we interviewed businesses across Oregon, we found that the main barriers to carbon footprinting for businesses are, number one, resources, both the time and the money to do this for their products. Number two, they needed clear guidance and education on how to do the work, right? Using life cycle assessment as a tool to measure the impacts of your products, and then disclosing that information is still new work for many people. And number three, we heard that there was a strong need for standardization to ensure fair and accurate footprinting, which is still something that we hear today. So this research really turned into our playbook for creating a valuable program within these different product sectors. And after this report, much of the work of my agency in one part of our program really started focusing our time on the food sector and the built environment sector. Today, for this talk, we're really just talking about built environment and specifically concrete. So why concrete? Kate talked about how the concrete has really high emissions. That's the same case here in Oregon. But we also have the available materials and methods to significantly lower those carbon emissions. Many, but not all, of these methods to lower emissions are cost neutral on a mix by mix basis. We'll talk about this a little bit more. And finally, we had a really engaged concrete industry here locally that really wanted to be a part of the solution and not just a part of the problem. Taking one step back to re-emphasize what Kate was talking about, when we look at global emissions, concrete comprises about 8% of it. So this is really important, and it's important for everybody. And we know for climate change, every single slice of this pie, we need to decrease this pie by about half in the next 8 years, and then again down to 0 by 2050. And for concrete in particular, when we look at the carbon footprint of a typical concrete mix, we see that the vast majority of that carbon footprint is in the cement. And this is the cement used. The cement is the binder that really glues all the rocks together. And when you make cement from limestone, it takes a lot of fuel to heat up the kiln. And then it also releases a chemical reaction of carbon dioxide into the atmosphere. So you kind of get a double whammy when you're making cement of both lots of fuel use and also chemical carbon dioxide coming off of the limestone when it's being heated. The primary method for reducing the carbon footprint of concrete is to use less cement. And when you're using less cement, you're really using these materials as supplementary cementitious materials. Most of these are industrial byproducts, things like slag and fly ash. We're starting to see other things being used, like metakaolin clay, also ground glass pozzolan, which we'll talk about a little later today. And here in the state of Oregon, we're now seeing natural pozzolans being used, which is basically old volcanic ash being used as a cement substitute. So there's lots of ways. These are just a couple of the main ways. We're not going to get into the nitty-gritty details, but there's lots of ways to reduce the carbon footprint of concrete. We were pretty excited about this, about all these different opportunities. So we designed a voluntary program in partnership with the Oregon Concrete and Aggregate Producers Association to help concrete producers across Oregon develop environmental product declarations, or EPDs, which Kate talked about. In this program, we aim to directly address the barriers to product footprinting that we found out in our previous research. And we did this by providing direct financial reimbursements for published EPDs. We provided direct technical assistance to help actually create the EPDs, and provided plenty of education on how to use EPDs for both internal and external purposes. We had really great partnerships with the Concrete Association, and worked with plenty of really smart concrete producers across the state and the program. Really impressed with all the folks that we worked with across this program. We ran this voluntary program for about 3 years. Overall, the program was a success. We worked with 10 different companies, over 21 different central batch plants, producing over about 1,500 EPDs across the state. Now, the goal of this program was pretty straightforward. We just wanted to get EPDs on the market. The more existing EPDs on the market would help project level decisions on choosing lower carbon mixes, but it would also help support broader policies. So speaking of policies, let's move on to talk about a few policies on the market here in Oregon. I'm going to start out kind of in chronological order here. Back in 2017, when Oregon Governor Kate Brown signed an executive order, Executive Order 1720, to address the built environment's climate impacts. One part of this order directs newly constructed state buildings to consult with my agency, Oregon DEQ, on options to reduce embodied carbon. Although our work with state building projects has been a little bit slow, I'm highlighting this policy because some executive orders can hold a lot of weight. You heard Kate talk about the federal GSA work on concrete and asphalt, and all of that work stemmed from an executive order. Now, EPDs are required for concrete and asphalt for federal buildings, and they've set carbon limits for concrete as well. So some executive orders can move policy quickly. Moving on to the city level, back in 2019, the city published a policy. City of Portland published a procurement policy that focused on requiring EPDs for the city's purchase of concrete. And so in January of 2020, they became the first city in North America to require EPDs for all concrete purchases. Literally just last week, they published their carbon thresholds for the different strength classes of concrete. And then all projects need to meet those limits starting in January of 2023. For Portland, they put their EPD requirements directly into their construction specifications, which is on the left side of the slide here. The specs say that basically any project that's using over 50 cubic yards needs to submit an EPD, and then also provides the email address that this EPD needs to be submitted to for approval. On the right, you can get a snapshot of the carbon limits that were just published last week for each strength class of concrete. This was very much a team effort, and there was an advisory committee that was put together to help the city of Portland come to these carbon limits and develop these carbon limits together. The other thing that the city of Portland does that I've realized is pretty unique to only some jurisdictions is that they publish and maintain a list of pre-approved concrete mixes that can be used on all of their projects. Now, in this list, I've highlighted the carbon specs published for each mix based on their EPD. Notice that I just called carbon, or the GWP limit, a spec. It's a specification. And at the end of the day, carbon is just another specification. Just like engineers have required concrete mixes to disclose things like air content and slump and water cement ratios, which are the other things listed in this table, they've just now added carbon to the list. Now, in some cases, it's really not that big of a deal in an industry that already manages a lot of detailed specifications like what is already done in the concrete arena. All right, now I'm gonna move on to highlight just one other city in Oregon, and this is the city of Bend in Central Oregon. The city of Bend recently published a community climate action plan that included an action to utilize low carbon concrete mixes in city projects and also create incentives to encourage developers to utilize low carbon concrete. Now, based on this plan, city staff have begun looking at past purchases of concrete to establish a baseline of what types of mixes they're already buying. You know, it's hard to know what your carbon footprint is if you don't start looking at it. This is a great example that demonstrates that you don't necessarily need an entirely new policy to begin work on concrete. Sometimes you just need some staff capacity and some management support to look at the current purchasing practices and figure out where there's room for improvement. All right, now let's move back up to the state scale here. You heard Kate talk about different Buy Clean programs. Oregon is one of only 4 states in the nation that now requires EPDs. In Oregon, they require EPDs for concrete, steel, and asphalt. Specifically, this legislation, which was House Bill 4139, just passed a few months ago in the February short session, and directs ODOT, which is the Oregon Department of Transportation, to require EPDs for a selection of projects to lower the embodied carbon of their material purchases. And like Kate was talking about, ODOT did a greenhouse gas inventory and found out their scope 3 emissions were really high for materials like concrete and asphalt, which is why they're focusing on their purchases. This bill was many years in the making and represents an impressive collaboration among material manufacturers, environmental and labor groups, government agencies, and of course, legislators. However, our work here is not done in Oregon. This bill only covers ODOT's infrastructure projects and does not cover vertically constructed state buildings like California or Colorado's legislation. So there is a policy gap here that could be filled in future sessions. Let's go to the next slide. Here's a few more details of the Oregon legislation. ODOT is hiring 2 new staff members to run the program. We at Oregon DEQ are really looking forward to working with them through the Technical Advisory Committee to help support lower carbon footprint of materials purchased. All right, let's move on to pilot projects now that we've covered policy. First off, why would you need to do a pilot project? It's important to know that ready-mix concrete is a field-cured material, right? So it's kind of like baking a cake in an outdoor oven. Any changes in ingredients or temperature can affect the outcome that you're aiming for. One thing we know is that lower carbon mixes have low early strength, and it takes a little bit longer for these mixes to come up to their final target design strength. Now, this does not mean that low carbon mixes decrease the quality or the durability of the concrete, but it may change how the concrete is poured or finished. So therefore, it's really important to engage engineers, contractors, finishers, and of course, concrete producers in a transition to lower carbon mixes. So that's why we do pilot projects, because it involves a large chain of people to make this possible. The first pilot project I'm going to highlight is on sidewalk ADA ramps within the city of Portland. The goal of this pilot project was to understand how the mixes performed. This was in the summer of 2020. Overall, low carbon mixes on this project met the city's performance specs. They were really well received by the concrete finishers. They were cost neutral, or in some cases less expensive, and they performed really well in the post-project visual inspections. And they did all of this while reducing the carbon footprint of the average sidewalk by between 25 and 35%. We were really fortunate to partner with the city of Portland on this first project. Since then, the city has continued to run pilot projects on their own to demonstrate the various applications for low carbon concrete. Here's a list of the pilot projects they've recently completed. All of their projects are focused on infrastructure applications, and all of these are posted to their website right now. I really encourage you to go check them out. I want to thank the contractors, the finishers, the city staff, and the concrete producers who have made all of these projects possible, because I think many, many other places in Oregon and beyond are going to benefit from these case studies. A special shout out goes to Stacy Foreman at the City of Portland for her excellent leadership on these projects. I just want to highlight a couple of findings from these projects. Overall, for infrastructure applications tested so far, one thing I can gain from these case studies is that roughly a 25% carbon reduction is achievable with little to no change in project schedule or finishing requirements. However, once you start bumping up to 40% carbon reductions in these different mixes, some of these may cause some schedule delays, especially on flat work applications, and some of these are really challenging in very cold weather. There are some ways to speed up the curing process, but you really have to balance those strategies with the contractor's experience. We're also doing and leading case studies at Oregon DEQ. This is a commercial building project called the Mill Creek Resiliency Building. This is down in Salem, Oregon, and it will house the Oregon State Treasury, which is why we were working on it. This is a resilient building. It was built to withstand a magnitude 9 earthquake here in the Pacific Northwest. But to make it resilient, the engineering team had to use a lot more materials in doing that. And so we calculated that the overall embodied carbon of this structure increased by about 25% due to the extra materials. This really large upfront embodied carbon footprint really drove the project team to seek deep reductions where possible. We worked with them to lower the carbon of the concrete mixes that reduced overall embodied carbon of concrete by about 25%. We've also been working on a residential project. Here's a couple of pictures from a fun residential project out in Damascus, Oregon. We partnered with Bird's Mouth Construction on pouring concrete mixes that achieved roughly a 40% carbon reduction from the originally planned mixes in this project. This has been a fun one because we're working with residential concrete installers who have absolutely never used low carbon mixes, and we're documenting their experience for others to learn from. We're hoping to publish the findings from this case study in July. The next two slides, I'm going to highlight a pilot project that we'd really like to do, but we haven't quite lined up. We'd really like to test the use of ground glass pozzolan as a cement substitute. You basically take bottle glass, you clean it, and then you grind it into a very, very fine powder. And when you combine this product with ordinary Portland cement, the glass becomes cementitious and can substitute for a portion of the cement. Now, I'm highlighting this because I know many folks who attend these webinars work in the materials management and solid waste fields. Many of you may have glass recycling challenges in your markets, just like we have here in Oregon. So we're hoping to solve two problems at once here by supporting ground glass pozzolan in concrete. The last thing I'll share with you here is some life cycle assessment data that helped reinforce for us at DEQ that ground glass pozzolan would be a beneficial end-use market for glass. Here's a chart from a recently released DEQ web-based tool. The address is at the bottom there, showing the global warming potential impact per ton of waste glass. Now, you can see the big green bar on the top there that goes to the right represents the carbon impacts of producing 1 ton of glass. Any bar that goes to the left demonstrates the carbon savings through different material recovery pathways. You'll notice the biggest bar to the left demonstrates the carbon benefits of recycling glass to pozzolan, which is the cement substitute we just talked about. Really big benefits when you offset the production of cement. Reuse of a bottle, where you're just washing it and refilling it, also has large benefits, and that's the big bar at the bottom. However, the more traditional recovery pathways for glass right now in the state, such as going to fiberglass insulation or recycling glass back into bottles, you can see here has significantly fewer carbon benefits. So this is the type of information that can help us prioritize recovery pathways for materials, and it can also help us encourage the growth of emerging technologies like ground glass pozzolan. All right, I know I'm running short here, so I'm going to try and wrap this up. I've got about 3 slides on lessons learned. Let's go quick. So in the first year and a half of our voluntary, so I'm going to kind of go back to the beginning here, where we did this voluntary concrete EPD program. I wanted to reflect that in the first year and a half of this program, we didn't produce any EPDs. There simply wasn't demand from the market. It wasn't until the first local building actually required EPDs did the program really get rolling. So the demand for EPDs is critical. It also became clear that some basic education, just like we're doing here today, was really helpful for all stakeholders because this is still new for people. We also saw that EPDs really do have value to concrete producers directly. For a couple of plants, we paired EPD development with an energy audit of plant operations. These audits identified energy, carbon, and dollar savings for the producer. We've also seen producers differentiate themselves in the market by showing lower carbon mixes. We've also seen producers change their source of materials because of trying to compete for lower carbon mixes. Overall, the concrete industry also is evolving with numerous new technologies, and we found that relying on a common measurement metric of an EPD really helps focus on the outcomes of these technologies rather than getting distracted by flashy advertising about this new technology versus this new technology. The EPD is kind of technology neutral, and it just gets to the outcomes. So that's one thing we really like about it. The next set of lessons learned was on pilot projects and partners we've had along the way in Oregon. This one's really important. We just talked about pilot projects for field cured materials like concrete and asphalt, so I won't repeat myself. But what I will say is that we're aiming for concrete and asphalt first because they're really high carbon materials. If you can tackle these materials, other building products are going to be a lot easier. Ready to install materials, don't take as much engagement with your entire, supply chain or construction engagement. For example, really, there's no change in construction practices when you're installing low carbon rebar or low carbon drywall or low carbon insulation. So other materials may be a little easier. The next lesson is about the immense value of engaging stakeholders in this work. Put bluntly, you can't do this alone, nor should you. I've learned so much from the concrete producers that I've worked with, the engineers, the architects, the public employees. And what I've typically found is that you're going to find many allies in every single stakeholder group, because understanding the carbon in our building products is a pretty logical first step to knowing how to reduce the carbon in our building products. A good example is the chart I'm showing on this slide. I worked with the Structural Engineers Association of Oregon to conduct a baseline analysis of structural concrete used in commercial office buildings in the Portland area. So that's what this chart shows. This chart shows the range of carbon footprint for mixes used in different strength classes in commercial buildings across the Portland area. This work was mainly done to support the city's procurement policy and provide a sort of a private market snapshot of how the private market is performing right now. But what happened in this is that this process led to every single engineer involved in this study became an internal champion of low carbon mixes in their structural engineering firms. And they now have taken that knowledge and that experience to every new project that they go to. So we've really raised the capacity by working on things like this. The final lesson here is that carbon is a specification. It's not that big of a leap to require EPDs and consider carbon in our decision making. We already label the efficiency of our dishwashers and our water heaters. It doesn't seem unreasonable to ask for how efficiently our materials are made. And at the end of the day, EPDs are simply measuring manufacturing efficiency. And this is information that people should know about. last slide, I promise, sorry to be behind here, is that some of the lessons learned from policy is that if you do choose to enact an EPD policy, I'd recommend a short timeline for disclosure. 1 year does seem sufficient. If you're choosing to set carbon limits, I do think it's okay to have slightly longer limits, a slightly longer time frame for setting limits for things like field cured materials like concrete and asphalt. In this case of City of Portland, they used about 2 years, which seemed to work well and make sense. For other ready to install materials, you're very likely to be able to go faster in setting carbon limits. Really, another point is about what to do during the year 1 disclosure period. It's really a great time to build relationships, look at past purchases, and conduct pilot projects if possible. Finally, and this will lead into Dorian's presentation, I think the most important lesson learned is to act now. You've likely noticed earlier in the presentation that we at Oregon DEQ have been laying down the policy breadcrumbs for many years, beginning with our statewide consumption-based greenhouse gas inventory. But today, I would argue that not everyone needs to do this. There's sufficient information already to justify action on purchasing lower carbon building materials. Remember, in some cases, you do not need a fancy policy. You just need a motivated staff member, some management support, and some management support to begin exploring some of your past purchases and looking for areas of improvement. So that's where I'm going to end it. Thanks so much for your time, and I'll stop here.
Thank you so much, Jordan. A lot of really great information, and had some great feedback in the chat around what you're presenting on. Let's see. Let's go ahead and ask a couple questions just for clarification. Someone in the chat had mentioned, or in the Q&A had mentioned, that they are new to this area, and they're wondering about how they could find out more information about how EPDs are calculated.
I'll pick that one up. I think that my presentation is actually going to go into some of the math associated with this type of work.
Okay, great. Well, do you mind if we save that to the end then?
Sure.
Okay, great. And then maybe this is more of a clarification question for Jordan, but how has the Oregon DOT adopted the low carbon mix in their construction specs? It sounds like it's more related to policy, correct?
Yes, correct. Currently, Oregon Department of Transportation does not have anything requiring EPDs in their construction specifications. Remember, this policy was just passed, and they're hiring people to start to develop and implement it at the moment.
All right, and then one last question before we move on to Dorian. Can you talk a little bit more about biochar in concrete?
Yeah, if this question is for me, this is new to me. I know of one local concrete producer who is experimenting with biochar in concrete. I honestly don't know that much about it. Biochar itself stores carbon, so I think they're looking for a sequestration benefit in that. I really don't know what material it is substituting for in concrete and what function it's playing, because I've only seen it in one local company, so it's still new to me. So if there's anyone else on the chat that can let us know sort of what role biochar is playing, that would be great to learn as well.
Jordan, it's Dorian, and I can tell you what I've heard about it. It does not have a pozzolanic capacity. It's my understanding that it's simply put into either concrete or asphalt mixes to serve as a sequestration, as like filler material that's sequestering carbon. But I have no knowledge of the performance of that type of material in concrete.
Thanks,
All
Dorian.
right, well, thank you, Dorian. Well, let's go ahead and move on to Dorian Bailey. Thank you again, Jordan, and we will get to more questions during Q&A. Dorian, I see your screen.
All right. Hi, good afternoon, everyone. First off, thank you, Jordan, for giving such a good lead into this presentation. I know you said you were going to bypass some of the intricate details of certain things, but don't worry, I got your back and I'm going to pick them up. Oop, that's the wrong thing. I might need a little bit of help on advancing. There we go. Okay, so this is some background on the Port Authority's Clean Construction Program. Back in September 2020, the Port Authority announced this program. There was a press release. What we were essentially coming forward publicly with is how we're moving forward with our construction business. We are trying to change business as usual to a manner that's much more environmentally conscious. One of the things that we announced and are incorporating is additional use of LEED and Envision. If folks don't know Envision, Envision is the infrastructure side of LEED. It's not out of the same entity, but it's from the Sustainable Buildings Institute, I believe, for Envision. Again, that's a program that helps us go after credits to make sure that we're doing things in either comparable to LEED, a silver, platinum, or bronze level. We, back in 2020, also made an instantaneous change to our low carbon concrete specification. The Port Authority's existing concrete specification allows for up to 400 pounds of Portland cement. We realized back in 2020 that some of our mass pour works could actually benefit from a further reduction. So for mass pour work, we are now working with a 300 pound limit. So that brought us down by about 25%. So this was right off the bat in September 2020. We also then talked about doing pilot projects for low carbon concrete and materials, and we have established a requirement for environmental products declarations. We do capture the request for environmental products declarations within our construction specifications. It falls within the Division 1 clause. Also, additional things that we're looking at in stage 4 construction is we also are a shop that requires tier 4 final diesel engines, and we have mandates for landfill diversion. So from September 2020, we moved over to June 2021, where we had a little catchy press release saying that we were cementing our commitments to clean construction. This was an announcement from June 2021 where we engaged the resources of local universities to help us really get a better feel for what our existing carbon baseline is for our concrete mixes and to see where we could go with it. So then in October 2021, we came out as an agency with our overall net zero goals and our climate ambitions. As Kate was mentioning, that there is this concept of a carbon accounting gap where these upstream emissions, the emissions of the products we purchase, are not being actually captured in our existing agency-wide greenhouse gas emissions inventory. But we believe that by capturing these emissions now and maybe handling them outside of our inventory, we can really start to push down our embodied carbon values for our concrete, asphalt, and construction materials overall. So this is going to be publicly available on our website shortly. Most of Jordan and Kate's conversations were about the provision of EPDs. So over here on the East Coast, we know that EPDs are not out there for all of our concrete suppliers. So in the interest of competition and just kind of getting the concrete suppliers acclimated to this new environment, we've come up with something that's completely different from what you may have heard in other talks of this nature. When we hired the Rutgers NJIT CATE team, CATE is the Center for Advanced Infrastructure and Transportation, they actually performed a very detailed statistical analysis of all of our mixes and gave us the ability to look at the actual constituents within our concrete mixes and essentially calculate what the A1 emissions from our concrete is from the raw constituents. So what's being shown here is a greenhouse gas emissions coefficient, where you can essentially look at the number, the pounds of raw material in your concrete mix. For instance, for Portland cement, we, again, our upper maximum is 400 pounds. So if we had a mix that was only coming in with 180 pounds of Portland cement, which we have had very low carbon mixes that are made that way, we would multiply that by the 1.048. Portland limestone cement is a big driver in the East Coast industry right now. I have been given the impression that most of our Portland cement is actually now becoming PLC. And what's nice about that is Portland limestone cement is almost a 10% shaving off of the regular ordinary Portland cement for the greenhouse gases. So you can see that we're dropping from an emissions coefficient of 1.048 down to a 0.951. The Kate report also has citations for all these other pound per pound emissions coefficients. So if you are an entity that is using substituted cementitious materials or supplementary cementitious materials, you can actually get a feel for what your A1 emissions look like by the formula that's presented on the bottom of the screen here, where you're just taking the pounds times the emissions coefficients for the raw ingredients. So by virtue of having this kind of back-end information, we were able to actually go through all of our historical mixes. We actually have our data from, probably about 1998 forward. And what we did to focus on what our historical emissions look like is we went to our 2006 baseline year for our agency-wide greenhouse gas emissions inventory. So we were able to utilize this formula on our 2006 mixes, all of them as discrete entities, and get a feel for what the GWPs looked like back in 2006 relative to where we are today, where we have incorporated this 300-pound maximum cement limit for mass bore work. And, this will get us forward in the absence of EPDs for all of our mixes. I think it's a very beneficial back of the envelope way of just getting a bigger feel for what those upfront emissions are from the raw materials within your concrete mixes. So this report and these factors will be up on our public facing website shortly. So again, it's another listing of the factors here. And really, again, I think some people get stymied by the fact that, well, we use XYZ manufacturer and they don't have any EPDs available, so we have no clue what this looks like. Again, by the Port Authority funding this work, I think it could give industry the ability to benchmark their concrete, even if you don't have an EPD. The way the Port Authority specification is written currently in that Division 1 clause for the provision of EPDs, we are viewing EPDs as the gold standard, but to prevent the delay of this work from our construction contracting partners saying that we can't get you EPDs, we are going to allow this formula just so that the Port Authority can have a better indication of what the A1 emissions, and again, the A1 emissions, that's the calcination reaction from the production of cement. It's really where 85% of these emissions reside when you're dealing with concrete. So it's the cement, again, in the concrete that's driving this. But you can see, based again on the chart, that there's other contributions from even if you're using fly ash, if you're using slag, we all view these as byproducts or co-products from different manufacturing industries. The way the formula was, or the way the determination was made for the greenhouse gas coefficients for these industry byproducts, actually we used an economic allocation method. So when we first started looking at this data back in 2019, we were zeroing out fly ash because it is just a byproduct. But since there's a price attached to it and based on the excellent work from Kate, we did agree to move forward with an economic allocation factor, which is part of the life cycle of those discrete products. So all that information is included in the Port Authority's report, which we will have on our website shortly. So the way the Port Authority is approaching the concept of limits for our concrete mixes is exclusively for the A1 emissions. EPDs are reflective of A1 to A3 emissions. The diagram here shows an Eastern concrete, 4,000 PSI cured for 28 days. And you can see here that the global warming potential is 203 kilograms per cubic meter of concrete. So there's a lot of math that goes into this, a lot of unit conversions, but then ultimately what we're doing is we're isolating exclusively the A1s. I'm not sure if you can see my cursor, but page 2 of EPDs actually will do a breakdown between the different portions of the EPD. So you'll have an A1, an A2, and an A3. Again, the total embodied carbon per this EPD is 203 kilograms of CO2 per cubic meter of concrete. But the things that the Port Authority has control over are the raw mix ingredients. The way our agency operates is the wonderful folks in our materials engineering unit actually do approve every single concrete mix that comes through our door. And much to Jordan's point, what we're getting at is just having CO2 as being another specification requirement. Our default concrete specification is performance-based. And what we're just going to do is include as a subsidiary a CO2 limit. So again, primarily the agency is focused on the performance of the concrete and knowing that these mixes will perform, but we are now starting to draw in this secondary metric for what is the CO2 content. So you can see here, you can go through a bunch of different calculations to convert your units, and now the conversion here for the A1 to A3, the 203 kilograms per cubic meter goes to 342 pounds per cubic yard. So the limits that we have been entertaining, these are not set in stone. We're still having a lot of internal debate about this. For mixes that are exclusively measured for flexural strength, we think we can go down as low as 415 pounds of CO2e per cubic yard, which translates to 190 CO2e in kilograms. What's a little bit interesting, when we looked at the 3,000 to 6,000 PSI range, we did find that there were certain cases where the 4,000 actually had lower GWP than say the 6,000. But they were all pretty close around these marks here. The proposed carbon limits that are being shown here were determined by the 50th percentile of all the GWPs in our concrete mixes as received between 2018 and 2021. So this was our evaluation of current concrete mixes and getting a better feel for what that 50th percentile was. So using these GWPs of, for instance, for the 3,000 to the 6,000, at a GWP of 425, half of our mixes were already meeting that and half of them weren't. So we kind of thought that this would be a good approach to draw in the rest of those concrete mixes that are not currently meeting. We're also contemplating an incentive structure to, rather than deal with the 50th GWP, maybe we could look at what are the top performing mixes, maybe only at the 25th percentile or the 20th percentile, just so we can see really how much further we can drive these values down. So just as a matter of history, the Port Authority has been using SCMs for over 20-25 years. So for us, we're not having the same hiccup with trying to process the concept of, implementing different supplementary cementitious materials. We are over that. We're also actually involved in a 2-year research project for ground glass pozzolans. One of the things our agency wanted to do when we started evaluating the ground glass pozzolan that is available in our region was to also make sure that there were no issues with something called alkali silica reactivity. So to test ASR via one particular procedure in ASTM, we are actually still cooking those samples for another, I think that will be up in March. But our original impression of the ground glass pozzolan is that it performs exceptionally well. And we don't think that there will be an issue in us incorporating that as another approved SCM in the future. So again, this is the table on the screen is really how we the values that we are fairly comfortable with. Again, we are only looking at them relative to EPD A1 values, which I know is a little bit different than most other entities. But again, because the A1 emissions from concrete are so incredibly high relative to the A2 and A3 emissions that are divulged on an EPD, and because we have control over the mixture constituents, right now what we're looking at is just trying to handle this from an A1 emissions standpoint until the EPD market evolves. And also to Jordan's point here, he made a lot of good commentary that this really is an emerging market. You know, this is a knowledge base that people are just now getting thoroughly immersed into it. As I mentioned, I've been working on it since 2019. It seems that Jordan in Oregon was ahead of us. But we are also privileged to have all this historical data on our concrete mixes. And I think that gives us the ability to move forward since we know every single concrete mix we've ever used. So this is just some duplicate information that I've already covered. We will be in the region right now, New York and New Jersey. Portland limestone cement is all over the marketplace. So we are accepting that as a new material now, and we are doing the subsequent accounting, which further drives down the GWP by about 10% based on those factors. So that was already included in there. We also had emissions coefficients pound per pound for the ground glass pozzolans, which we'll be sharing too. We've also been looking at CO2 impregnated fly ash. You know, we're doing a lot of things to figure out beyond SCMs what else we can do to reduce our GWP of our concrete mixes. And that was all I had. Thank you.
Great, thank you so much, Dorian. We had a lot of great questions coming through. And now we are into the Q&A section of the webinar. I will go ahead and ask you a few questions that are pretty specific to your presentation, if you don't mind.
Sure.
So one potential barrier for using low carbon concrete might be related to cost. This might be for both you and Jordan, actually. Does the Port Authority expect to pay more for these lower carbon concrete materials?
No, my understanding is that everything that we're currently doing with SCMs is cost neutral.
Great, thank you. Can you also elaborate on what's included in the A1 through A3 impact areas?
Sure, A1 to A3 emissions are the emissions that are divulged on an EPD. So that is the gathering of the raw materials and the processing of the raw materials. Jordan covered this exceptionally well about the calcination reaction for the clinker manufacturing, which is the precursor to cement, and that is liberation of calcium carbonate, CO2 gases from the superheating.
Great, thank you. And then one last question before I open it up more broadly. Will the proposed New York, New Jersey carbon limits based on historical mix results be calibrated downward once type 1L cement becomes the default in your market?
That's a good question. The way we're looking at this, we were going to stick with, whenever we get our limits out there, we're probably going to stick with them for a 1 to 2 year period. We are on a trajectory to have a 35% reduction by 2025. And that's on our website as well. So what we're trying to do is put the agency's emissions reductions on the construction material side in parallel with the climate change ambitions that our Office of Sustainability has. So we're trying to move everything down in the same trajectory.
Great, thank you for clarifying that. Then, sorry, one more before I open it up a little broadly. This seems to be more specific to you, but are the greenhouse gas coefficients from the CATE study that you referenced, is it location specific, or can they be applied? Okay.
It was our location specific. So the CATE team sourced, got EPDs for the type of materials that we're using specifically.
All right, great. Thank you, Dorian. So we have a bunch more questions. We'll get through as many as we can. This one is more specifically for Jordan. Jordan, what have you seen as the most effective way to meet project global warming potential targets for concrete and specs? List a percentage reduction or a specific GWP target by mixed design.
Sure. I think that using targets per strength class has been really effective. This is essentially what the city of Portland just released, and kind of similar to what Dorian spoke about. They have slightly larger ranges of strength classes, but I think targets per strength class has been really successful, and one important aspect of that is also allowing project averaging in a given project. So for instance, if you're pouring a huge mass pour foundation where you're able to really lower the carbon footprint of your mixes because it's a foundation that doesn't need to cure quickly and you can leave the formwork on longer, those are the places where you can really aim really, really low. Whereas if you're doing like a post-tension slab elevated floor system, you're probably not going to be able to go as low on the carbon footprint due to schedule concerns. So if you're able to average those out among the project, so you're getting more carbon savings in the foundation and less carbon savings in the floor, that seems to be a best practice that construction teams really appreciate, because it allows them to target areas that are easier or for carbon reduction. So I'd say that's a good one. If you do not have carbon targets as a policy, the National Ready Mix Concrete Association publishes regional benchmarks that are basically carbon footprints per mixed strength per region of the country. Those are a really good one to put in your specifications as well, to say, we want to see mixes that at least meet the NRMCA regional benchmarks in our region. We saw that used a lot on individual private building projects prior to having, the City of Portland specs up. So those are a couple of things I'd recommend.
Thanks, Jordan. So someone in the Q&A had a question around using low embodied concrete in the infrastructure world. They're pretty familiar with it in the vertical / buildings construction area. And they recently tested it for sidewalks. So Jordan, this might be more for you, but the crew found its workability to be more difficult than anticipated. Is this a training related thing or a material thing, or maybe it's both?
Sure. I think it's a little bit of both. And, Dorian can probably speak to this, and you heard us talk about, her values are sort of specific to her region. And in this case, concrete changes in different areas of the country because your material sources change. And so I think it's difficult to draw definitive conclusions on how a sidewalk is going to perform in Portland, Oregon versus, Southern Georgia. So the rocks that you get are going to be different. The cement that you get might be a little different. I do think that's one of the reasons why pilot projects using your local materials are really important. That said, with sidewalks, our experience here has not been that they've been more difficult to work with. In some cases, we've had people prefer working with them because they actually take a little bit longer to set up, which gives them more workability to spread the concrete out and either vibrate it into place. And then what we have heard on certain low carbon mixes for sidewalks is that it takes a little longer to set up, right? So that means you want it to get to a certain level of hardness before you broom the concrete, right? This is before you're making those little lines in the sidewalk and stamping the edges and doing things like that. So sometimes your crew might be on site for an hour or two longer than they may be normally, depending on how aggressive your low carbon mix is on sidewalks. This is especially prominent in colder weather, where in general, whether it's low carbon concrete or not low carbon concrete, the concrete takes longer to set up in colder weather. So weather is a factor here. Yeah, I'd encourage you to check out some of the case studies on there, and there's a couple. Hopefully that helped answer the question.
I think so. Thanks, Jordan. So in general, I think you might have covered this question a little bit, but if you could also speak to the durability and lifetime as standard Portland cement, can you talk a little bit about the durability there as it compares to low carbon concrete?
Well, I can talk about the durability of our concrete mixes in general. And as I mentioned, we've been using SCMs. I believe we might even have, I think our specification is a 30% minimum. So most of our low carbon concretes are already, most of our concrete is already low carbon concrete by virtue of the SCMs that's already contained in it. And we did this many, many years ago. I believe it was about 25 years ago for the purposes of cost, and how these SCMs at the time, and even still, are cost neutral relative or even lesser than the cost of cement at the time. And we have very good history with working with them and all kinds of durability data.
Great, thank you, Dorian.
I would just add that we often see that, sometimes these SCMs are being used on mixes without people even knowing it, right? And that's not just right because of cost, but they can produce a denser and more durable concrete than you would otherwise get to produce, and they're also make your concrete a little less permeable than you would normally have it if you just had ordinary Portland cement. So there are actual performance benefits to using some of these SCMs, which is why we've been using them for such a long time. And I think what many of us are trying to do is say, okay, we've been using a little bit, but how much more can we use without sacrificing cost or durability or performance and optimizing carbon reduction?
To that point, I believe one of our we are still doing a pilot project at JFK where we're really trying to push the boundaries. I think one of the mixes we're dealing with is 70% SCM. So once that data is available, we'll also have that published.
Great, thank you. So let's see. This one is related more to the SCMs. So beyond just using SCMs to replace a portion of Portland cement, are there also initiatives to find and promote alternative types of binders that are made through less carbon intensive processes? And along with that question, are there low carbon concrete projects that use dredge materials like sand, silt, and clay?
I'll take the dredge material. You can't, you would have to wash it. You can't have salty sand, otherwise it facilitates corrosion. What were the other questions?
Just around what other alternative types of binders that are used for a less carbon intensive process.
I believe that there are polymeric organic binders or geopolymer binders. We've not played with them or investigated them. I think, as the future unfolds and we have to become more aggressive with these things, we might start looking for some other substitutes for the binder. But back to the point about acting now, because we can control these A1 emissions in our approvals process, there's no reason for people not to be more carbon conscious in the mixes that they're selecting.
So we've got just a few more minutes left in our time together. I just want to, someone had a more general question about how do we do this? We are in a smaller town. How can we apply this to our town's procurement? And maybe you could point to some specific resources that our attendees could look at.
I know Kate is gone, but the CLF planning tools are a very good option.
Yeah, I would agree. CLF has a wealth of information available on their website at various levels if you're trying to educate yourself or others. And I'd say for anyone just starting out and wanting to do something about this, the first thing I do is go talk to your concrete producer and ask them, you know, what types of mixes are available for whatever application you're using it for, right? And you know, when you order a 4,000 psi mix, they probably have 10 to 20 different mixes that they could make that meet those strength requirements. And so I think that's the first step, is just talking to your concrete producer. They've got the knowledge, the materials, the methods. Sometimes we've found in more rural areas that one of the barriers to lower carbon mixes is just having the storage capacity for alternative SCMs. Like if you only have one silo at your concrete plant, you're going to put cement in that silo. If you don't have a second silo to put fly ash or slag or glass pozzolan, that is a barrier. There's ways around it. There's blended mixes. There's other things, storage things that you could put on site. But I'm just relaying something that I've heard from smaller towns that have maybe smaller producers in them. So I would just start a conversation and ask your concrete producer what they could supply.
Great, thanks, Jordan. And CLF, if you missed that, is the Carbon Leadership Forum. So if you're looking for information on incorporating low carbon concrete purchasing, they have a really great toolkit that you can find on their website. Let's see. These questions are around glass pozzolan. What are the biggest barriers for using ground glass pozzolan, and what's the emerging supply status of using this material?
I can give some contact information for the East Coast, where it's coming from. I think Urban Mining might have a depot. It's been around for a couple of years where they've been asking for us to embrace this product, and this ASR test is literally in its second year. But all the original breaks and everything done on stuff made with GGP was all looking good. It definitely does seem promising. We just can't officially go forward with it until we have that 2-year ASR testing data.
Got it. Thank you, Dorian.
I was so excited to learn that you're doing this work, Dorian. I had no idea you were doing this long-term work on glass pozzolan, so excited to connect with you afterwards. I would say the biggest barrier to glass pozzolan is supply. It's, we don't have any on the West Coast, we have a lot of glass recovery issues. So we would really like a manufacturer to set up shop here somewhere. And that's the biggest barrier. I would say specifications aren't a barrier, right? There's an ASTM standard passed a couple of years ago that now allows you to use glass pozzolan. Oregon Department of Transportation is working on putting glass pozzolan in their specifications as well, along with natural pozzolans. And so, it's just getting the material here and getting it through a couple of pilot projects, I'd say are the next steps.
Great, thanks, Jordan.
Teresa,
go ahead.
Thank all of you for your questions. I think we're close to being out of time, but I never really appropriately introduced you, Teresa, and I'm sorry. So why don't you just say a few words about yourself and your involvement in the West Coast Forum.
So I'm Teresa Blaine with the Environmental Protection Agency out of the Region 10 office in Seattle. I work on the Sustainable Materials Management team, focusing on the built environment, and with great partners through the West Coast Climate and Materials Management Forum with NERC and NOMOA. Thank you so much for having me help out with this webinar. I learned a lot. And I want to leave with one last question around the federal purchasing, just because I'm with EPA. So there was a question around when low embodied carbon concrete standards are projected to be implemented into specs for federal projects. And I would say go look at what GSA is doing. They released some press release back in I think it was February this past year around how they're going to reduce emissions from building materials through low embodied concrete. So I don't know the exact date, but I know GSA is the one that's been working quite a bit towards this. So I will turn it back to you, Terry.
Well, thank you. Maybe we should, or maybe we should encourage them to have a webinar like this on what GSA is doing at some point. Maybe put a bug in their ear, because we did get some questions about that in the questions. So thank you all. This was a great webinar. I learned a lot, really excellent presentations and a great topic. Again, I want to mention before we end all of this that we will be posting the slides as well as the recording of this webinar on the, probably first will be NERC's website, which is the Northeast Recycling Council, the NMOA website, which is the Northeast Waste Management Officials Association, and the West Coast Climate and Materials Management Forum website. So all three websites will have all the information from today's webinar posted on them. And I want to wish all of you the best and have a good day, and thank you so much.
Thank you. Bye-bye.
Bye-bye.